Hey everyone, how are you today? We are going to be working on problems that involve rates and ratios. So go ahead and get out your notes and start writing. Of 100 students surveyed, 25 said they would vote for Jen for class president. If 2,000 students voted in the school election, about how many votes should Jen receive? One of the things you need to do is we need to start looking at the question. And so we're looking out of 100 students surveyed, and 25 said they would vote for Jen. So I realized that this is a part and this is the whole or total. Super important to understand that, and that these two are associated. Okay. And then I'm looking at the rest of the problem. It says if 2,000 students voted, this is another whole. And then about how many votes should Jen receive? This is our missing part. That is what we're looking for. So in my understand box, we're going to understand that I have a part to whole relationship equals part to whole. Super important that you understand that. And that means I am using a proportion. So my plan is to set up a proportion making sure to label. And cross multiply, cross products, or scale factor, whichever one is easier for that particular problem. So I'm going to solve, and I'm going to start with my blue ones, and I'm going part to whole. So my part was 25, my whole was 100. And I'm going to change over to my greens. I'm doing part to whole here. Notice they're both parts and both wholes on the bottom. Parts go on top. I have 2,000 here, and this is my I don't know. There's my question. Now, I could cross multiply, but I'm going to be honest, scale factor here is actually quicker. So you could bat and ball it, or you could go, well, what do I do to 100 to get to 2,000? And my answer is multiply by 20. And whatever I do to the bottom, I need to do to the top. So I multiply by 20, and I get 500. And then I can check that by setting it up 500 over 2,000. And I can just go ahead and cancel 1, 1, 1, 1. That gives me 5 over 20, which I can then divide 5 out of 5. And my answer is 1/4. And when we look at this originally, 25 out of 100 is 1/4. So that does check. Let's go ahead and take a look at another problem. It says the decorating banquet committee for the school banquet decides to put on flower arrangements on each table. Each arrangement will have 3 white carnations and 5 yellow carnations. The committee will need 60 white carnations. What is the total number of white and yellow carnations the committee will need? So I have 3 white, 5 yellow. I need 60 white. What is the total number of white and yellow? Oh, this is a ding, 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 ding right here. They want white and yellow. So I know I need to add them together. It is important that you notice that while you're reading the problem, because if not, you're going to either give me white or yellow. You're not going to give me total. So total number is that key that's telling me that I'm going to add them together. So I have 3 white. Ooh, that was a really weird W. And 5 yellow. I have 60 white. And the question is what is my total? And I'm going to star that, be careful. So my plan is part to whole. And be careful because you need to add your white and yellow to get your total. Well, I have 3 white plus 5 yellow gives me my total of 8. That is the first thing I have to notice, is because I want total. And then I'm going to start with 3 white carnations out of 8 total carnations, not 5 yellow carnations. Because my second part was this 60 white and total number. So I have 60 white carnations here, and I don't know how many total here. So once again, you can either do bat and ball, multiply across, then divide, or I notice right here, I can multiply this by 20. Whatever I do to the top, I also do to the bottom, and I get 160 total. And you could check this because this is simplified. I could come in here and simplify this to 6/16 and divide that by 2, and I get 3/8. And look at that. They match. We are good. Question number 3. Allie ran 5 miles in 36 minutes. Sammy ran 6 miles. If Allie ran at a faster rate than Sammy, in how many minutes could Sammy have run 5 miles? So the thing I'm noticing is that I'm doing miles per minute. Okay, and so I have Allie, and I'm going to do Allie in green. She does 5 miles in 36 minutes. 5 miles in 36 minutes. And then I also have Allie ran faster. Allie is faster. And then I have Sammy. Sammy ran 6 miles in question mark minutes. So my plan is to realize that Allie is faster than Sammy. That's important. So Allie's rate is faster than Sammy's. And then I am going to use cross products, which is a proportion, and realize that I have to choose an answer bigger than Allie's time. So I'm going to come down here, and I have, Allie is 5 miles in 36 minutes. And then Sammy is 6 miles in I don't know how many minutes. So this one is when I'm going to cross multiply. So I'm going to multiply across. 36 times 6 is 216. And then you divide by your leftover. So the minimum it could be is 45. Here's the problem. Remember that Allie runs faster. So this would be Allie's time, 45.2. This is Allie's time. Sammy is slower. So my answer has to be bigger. So when I look at my answer choices, the only answer that is bigger than 45 is 48. So 48 has to be Sammy's time. Okay, Kevin plays football, quarterback on his football team. The table below shows the number of passes he threw and the number of passes he completed in 4 games. At which game did he have the highest completion rate? And this is our important part. Highest completion rate. So this is looking for the biggest number. So I am going to come in here and I am going to understand that I'm looking for the highest rate or biggest number. And there are 4 games in the table. My plan is to change to a percent or decimal to go ahead and figure these out. I personally think it's quicker than doing 4 proportions because then I can compare them. So we're going to solve and we're going to look here. I'm going to do completed overthrow every time. So time 1, let's do this in red. Game 1 is 15 out of 25. We're going to simplify that by dividing by 5. That gives me 3/5. 3/5. Hopefully you remember the hand trick. 2, 4, 6 is 60%. If not, you would divide this and solve that. Okay, we're going to do game 2. And game 2 was 10 out of 15. I can divide that by 5 and get 2/3. 2/3 is a benchmark fraction, 67%. Game 3 over here is 15 out of 30. I can simplify that by dividing by 15. That is 1/2. 1/2 is 50%. And then game 4, we'll squeak in here, 12 out of 20. I can divide this by 4/4. That gives me 3/5 or 60%. Remember, we're coming in here looking for the biggest one. The biggest one is right here. So game 2 had the highest completion rate of passes. Okay, last question. Charles wants to visit his family 1,400 miles away. His car can travel about 25 miles on 1 gallon of gas. It takes 15 gallons to fill the tank. What is the best prediction of the number of full tanks of gas it will take Charles to travel that distance? We're going to come in here and we're looking at, ooh, that was crazy. 1,400 miles away. And then he goes 25 miles on 1 gallon, 25 miles per 1 gallon. That's going to be important later. It takes 15 gallons of gas to fill the tank. And I want to know best prediction of full tanks of gas it will take to travel. So first thing we need to know is that whole 25 miles per gallon. There are 15 gallons in 1 tank. I'm going to use a proportion. And then to see how far 1 tank goes, to get 1 tank. So I'm getting a unit rate, to be honest. And then I'm going to divide the total miles by the miles per tank. So here we go. I have 25 miles per 1 gallon equals how far? 15 gallons, because that's what's in 1 tank, right? Well, I'm going to multiply by 15. Whatever I do the bottom, I do to the top. 25 times 15 is 375 miles. This is our key number. Now I can figure out, because I know that is 1,400 miles away. 1,400 miles divided by 375, because that's how much gas is in 1 tank, or how many miles he can drive in 1 tank. And I get exactly 4. So it will take him 4 tanks of gas to go 1,400 miles. That's all I have for today. Good luck on your DOL, and I will see you later.